welcome you all for the new chapter, that is chapter number 6, heat and energy. So first, starting with this chapter, what do we discuss is the concept of heat and temperature. You all know that heat is a form of energy, but what is temperature? It is a quantity which we measure the heat. So among heat and temperature, first let us discuss what you mean by heat and definition of heat and SI unit of heat and conversions of heat energy. Then we will go to the concept of what you mean by temperature. Understand there may be a difference between heat and temperature. So till now we will discuss in today's class. So first let me consider what you mean by concept of heat. What is concept of heat? You might have all seen heat means many number of things which will be flowing in your mind. Now let me explain what actually the heat is and heat energy. The heat is produced either by doing work. That means heat is being produced either by doing work or by providing energy. One is it is by doing work or by providing energy in some form other than heat. To explain this, how heat is produced by doing work and by providing energy, let me consider two examples in each cases. First, consider an example of rubbing your palms. Rubbing your palms. Rubbing your palms. Second example, blowing air. Blowing the air. Blowing the air to the bicycle tube. Okay. Next, third example I will consider. Flow of the current. The current flowing in a metallic conductor. Metallic conductor. Fourth example I will consider burning of coal. Burning of coal. See, this four example I have been taken to make you to understand the concept of what we mean by heat. Okay. Now before that I told you, heat is produced either by doing work or by providing energy. Now first one is rubbing your palms. Just rub your palms for nearly 30 seconds. What will happen? Heat is being produced. What it is? Heat is being produced. Heat is produced. Right? Now, blowing the air to the bicycle tube. When you are blowing the air to the bicycle tube, what happens to the blowing this? The machine which you are using to blow the air. What happens? You just feel it, and have you come across, because all of you have a bicycle. When you just touch it, what happens? You will have the you can feel that it is being heated up. Then a current flowing in a metallic conductor. A current, if it is being keep on flowing in a conductor, just when you touch it, what happens? You will feel that there is a heat. Then burning of coal. When a coal is being burned in front of you, what do you feel there? You feel it is very much hot. Means heat is being produced. But in first and second case, heat is produced either by doing the work. Right? Here we are doing the work, that is mechanical energy. We are doing mechanical energy is converted into heat energy. Right? Mechanical energy is converted into heat energy. Is it not? We are doing the work because we are rubbing our palms means we are doing the work. Hence it is being mechanical energy is converted into heat energy even in this case, because we have to blow the pump. When you are blowing the pump, what happens? Heat is being produced. In the sense, mechanical energy is converted into heat energy. Here, a current is flowing in metallic current. Conductor. What energy is being flowing? Electrical energy. Right? Electrical. In this case, electrical energy. Electrical energy is converted into what energy? Heat energy. Or we can even call as chemical energy is getting converted into heat energy. Even that is heat. Understand? And what about burning of coal? When a coal is burning, means there is some chemical reaction which is being happening, obviously. So we can take chemical energy. Chemical energy is being converted into energy. So you are understanding that. See, there is a 2, 3. First and second is by doing work. Heat is being produced by doing work. Where third and fourth example is by providing energy. In this case, electric energy is provided and heat is being produced. Obviously, here, see now you can see that when you touch some of your apparatus in your home, whatever you have like fridge or whatever, a TV, it produces heat. That is called as next year you will come to know that heating effect of electric current. That there we can discuss. But in general, we know that current flowing in a mechanical conductor, it converts electrical energy to heat energy. Then what about burning of coal? Obviously, chemical energy is taking place into heat energy. Means, what did we understand out of this core example is a heat is being produced by two things, either by doing work or by providing energy. A doing work in the sense mechanical to heat energy, or by providing energy in some other form other than heat is, that is electrical to heat energy, chemical to heat energy. Understand? Thus, by all this we can tell, we can make a statement: heat is a form of energy. Heat is a form of energy. Right? Heat is a form of energy. And not only heat is a form of energy, we know that even sound is a form of energy. Is it not? We will tell sound is a form of energy. Sound is a form of energy. Then which one we have to? Even light, yes, light is a form of energy. Light is a form of energy. Even now you have taken heat is a form of energy. See here, sound is a form of energy. Sound energy we can hear. We can hear. Sound we cannot see, but we can hear. Light is also a form of energy. Light we can see. We can see it. We can see the light energy. Heat is a form of energy. What about heat? We can feel. Right? Look at here. How beautiful it is. Right? See, light is a form of energy. This light energy we can see. Sound energy we can hear. Heat energy we can feel. But all three are what it is? It's a form of energy. When you come to biology, food is what it is? It's a form of energy. You can tell that food is a source of energy or something. Like when you eat food, what happens? When you eat food, it converts into glucose, then something and all, it will be happening inside your body. Then it gives us what you need by energy. Right? Food is like that. You have energy is the capacity to do work. Long means again. So these are the things you need to understand. So we can tell that by all this example, heat is a form of energy. And even we have told sound is a form of energy, light is a form of energy. Light we can see, sound we can hear, and also heat we can feel. Understood? Next, let me go and explain you that. Consider some body. Example. I have considered some body. All the body, any body when you consider, it is made up of what? It is made up of what we mean by molecules. Right? It is made up of what we mean by molecules. These molecules, it will be in a random motion inside an object. If it is inside an object, it will be it is in a random motion. Like it will be keep on hitting the surfaces of the walls like this. It will be in a random motion. Means kinetic energy. It is having what? It is having a kinetic energy. Or the internal energy we can call. We can call call whatever the energy inside is known as what you mean by internal energy. Okay. Now, if this body is hot, if the body is hot, think that if this is a hot body, then what happens to the random motion of what happens to the molecules which is inside is the random motion of the molecules is more. The random motion of the molecule, the random motion of the molecule is, understand, or the internal energy is more. The internal energy, whatever it is having, the internal energy, whatever it is having, is more in the case of what you mean by the body which is being hot. Comparatively, when you take the body is cold, what happens? The random motion of the molecules is very less when compared to that of a hot body, right? And the internal, whatever the energy which is being happening inside, the random motion, I am considering as what you mean by internal energy. Understand? So, for example, now let me consider hot body. This is being cold body. So when you kept hot body and cold body together, what happens? We know that there is heat passes from hot body to a cold body. Means the internal energy is being transferred from hot body to the cold body. Understand? Until when? Until both of the temperature comes to the same point. Right? Understand? For example, this is 100% hot. What happens? It transfers 50% heat to this until both have become cold. For example, when you take both cold bodies, there will be no exchange of what we mean by hotness between the two things. Understand? So this is what the concept of what we mean by passing of heat energy. And this is how the heat body turns out. Now, for example, you might have seen when you touch, like when you touch the hot plate, I will do here. When you touch a hot vessel, what happens? You suddenly take your hand like this. Means in that case, when you touch your hot plate, the heat is passing from vessel to your body. Vessel to your body. That is the reason you feel it as hot. But when you have ice cubes in your hand, okay, when you have ice cubes, what happens? You feel cold. Why you are feeling cold when you have ice cubes? Is that because when you have ice cubes, heat flows from your body to ice cubes. So that is the reason when your constant heat is flowing from your body to ice cubes, it starts melting. Understand the concept? See, one thing has a hot vessel. When you touch a hot things, anything, you feel hot. The reason is the heat is passing from vessel to your body. But when you catch the ice cubes, you feel cold. What is the reason? Because heat flows from your body to ice cubes. So understand the differences, whatever. So now we will define what we mean by heat energy. Then we will see what are the SI units and CVS units and conversions, all the things, and what is a calorie and all. Then we will move to what we mean by temperature and see the differences. Now we will see how to define the heat. So heat is the internal energy of the body. Internal energy of the molecules. Heat is the internal energy of the molecules. Heat is the internal energy of the molecules constituting constituting the body. Constituting the body. Heat flows from hot body to a cold body. Heat flows from hot body to a cold body. So this is how we can define heat. Okay, heat is the internal energy of the molecules constituting, because we know that, right? When you consider any body, it has some molecules. It is made up of molecules. So what happens to these molecules when it is a hot body? When it is a hot body, the random motion of the molecules is more. Means the internal energy is more. When you get a cold body next to the hot body, what happens? The internal energy is being shared from here to here. Then obviously what happens? Here internal energy decreases because it is being flowing from hot to cold body. Here internal energy decreases. Here internal energy is increases. Internal energy increases. Remember this. Internal energy increases. Understood? So molecules constituting the body, heat always flows from hot body to the cold body. So I hope you have understood what do you mean by concept of heat. Now let us see the units of heat. Units of heat. So SI unit of heat, because we call it as heat energy. Right? What is the SI unit of energy? Is the same thing, the unit of heat. What is the SI unit of energy? SI unit of energy is joule. So even SI unit of heat is also joule. So what is its CGS unit? CGS unit is R. Here also it is R itself. CGS and SI unit of heat is same as that of energy. Now what is the relation between SI and CGS unit of heat? That is 1 joule is equals to 10 to the power of 7 R. Understand? This 1 joule is equals to 10 to the power of 7 R. And also higher units, other units are, what are the other units are? Calorie and kilocalorie. Calorie and kilocalorie are units of what? Now how kilocalories and calorie are related is 1 kilocalorie. 1 kilocalorie is equal to 1000, because you already know kilo means it is 1000 calories. And how, for example, sometimes they ask how calorie and joule are related. How calorie and joule are related. Calorie and joule are related, right? 1 calorie is equals to 4.186 joules. Very important. This even in your 10th standard they are going to ask this. Otherwise you can round up from right 4.2 joules. Even this is correct. This is how calorie and joule are related. So 1 kilocalorie. And these are the SI and CGS. It's very important. So I hope you have understood the complete concept of what we mean by heat. Now we will move on to the temperature. Now after knowing the complete thing of heat, now let us move to the second concept of today, it is temperature. So what do you mean by temperature? Temperature, you have heard a word. Like when you study your measurement and experimentation chapter, you have 7 fundamental quantities: length, mass, time, electric current, temperature, amount of substance, radius. Have you not known that to find out a solid angle? Right? So those are it is one of the quantity, it is one of the fundamental quantity, it's not a derived quantity, right? It is one of the fundamental quantity which was known for a long time. So temperature is a quantity which tells us the thermal state of the body. Temperature, which instrument we use to In thermometer, we have different types: clinical thermometer, laboratory thermometers. Thermometer is totally a device which is used to measure the temperature of the body. Means, what do you mean by temperature? Heat is a form of energy. Temperature is a quantity which measures the heat, which measures the thermal state. Thermal means it is heat or not. Thermal state. Right? It's a standard science word we use for heat is thermal state of a body. That thermal state means whether it is degree of hotness or coldness. Whether the body what we have taken is hot or cold is known by temperature, and the device which we use to measure temperature is thermometer. Understand? Now, it determines the direction of flow of heat when two bodies at different temperatures are placed in contact. For example, let us consider body A and this is body B. Okay, now let us consider in Celsius. Okay, temperature, this is going to happen, this is 50 degrees Celsius, this is having 30 degrees Celsius. Now I took thermometer and measured the temperature of that both. Means I came to know the thermal state of the two bodies. How did I get to know the thermal state? By measuring the temperature by a device called thermometer. It showed 50 degrees Celsius. It showed 30 degrees Celsius. So obviously, which is hot body and which is a cold body. Temperature, if it is more, it is called as a hot body and it is a cold body. Right? This is hot body and this is cold body. Now, it determines now direction of flow of heat. Means molecules random motion is more here. The internal energy is more, here the internal energy is less. Obviously, when both of them is kept together, what happens? The internal energy flows from hot body to a cold body. Means it determines the direction of flow of heat. When here the direction of flow of heat is this direction, that is from A to B. Means which is determining temperature is making us to understand. So this is what without touching we can find out. If it is a very hot body of 50 degrees Celsius, can you touch in our hands? No. We use thermometer to find out. For example, when you get a fever, they measure the temperature of your body, right? By using what? Clinical thermometer. Based on that, some will make us to keep your below the thermometer. Some keeps in neck below, that to know the internal temperature of our body. So this is what you mean by concept of temperature, that is temperature definition. And we have three important notes you should know in the case of temperature. What it is? See, if there is no transfer of heat, when you put two bodies together, if there is no transfer of heat between the two bodies, let's be in contact, then they are said to be at same temperature. If there is no heat flowing from one body to the other body which has been kept, then what it is said to be? It is said to be having same temperature. Understand? And temperature alone does not tell us the quantity of heat energy contained in the body. Now, some body I have been here. Only temperature will not tell me what is the internal energy present in the body. Only temperature is not a parameter to tell that, to decide that what is the thermal state of the body. So, which are the three other factors? One is mass, temperature, and material of the body. Mass also differs. For example, when you take heat and a small, both may be at the same temperature, but temperature may be same, but internal energy is more here, internal energy is less here. Understand? So it depends from material to material, that is mass. It depends on what? Mass, whatever you are taking. Then it is temperature and material of the body, which material you choose. That is what, for example, in the case of fuse, we choose which has a high specific, low specific capacity. So copper, why we are using the electricity? Because it has high specific capacity. So those are the things. About this you will study next year, calorimeter chapter, and even household circuits, all those things we will study. Understand? So these three are very important. This is a very important option. Right, understand? And temperature. I hope you have understood the concept of temperature. Now we will see the units of temperature, that is calorie, Kelvin, Celsius, Fahrenheit. You know that obviously. We will see what it is. And the difference between what we mean by temperature and heat is given in your textbook. Please go through it. Understand? Then it is up to you. Nearly 6 points are there. Learn all those. It's very important. Now we will see the units of temperature. Now we have the SI units and of what you mean by temperature and the other units also out there. Then the SI unit of temperature unit is Kelvin, right? So Kelvin is a name which has been given after Lord Kelvin, who did some work on its temperature things. Okay. Now the other units of temperature we call it as degree Celsius. Celsius is also a scientist name. Degree Fahrenheit. Fahrenheit is also a scientist name. All the three things are the scientist name itself. Like Lord Kelvin. Kelvin is the SI unit. And the other units are degree Celsius and degree Fahrenheit. Now let us see how Kelvin and Celsius are related. How Kelvin and Celsius are related. So what is the? It is, if you want to be Kelvin, temperature in Kelvin, you see 273 plus, you need to add in 273 temperature in degree Celsius. For example, you can consider ice at 0 degrees Celsius. Ice at 0 degrees Celsius. 0 plus 273 give me 273 Kelvin only. Right. Then if you want to take steam at 100 degrees Celsius. Substitute 100 degrees Celsius here. 100 plus 273 is 373 Kelvin units. When you are adding 273 degrees Celsius converts to what you mean by Kelvin. It's very important, and you were knowing this right from 6th standard also. Now we have how the Celsius and Fahrenheit are related. So this is the formula for that. Remember this. It is C by 5 is equals to F minus 32 by 9. Means 1 Celsius scale. 1 Celsius is equals to 9 by 5 of Fahrenheit. Fahrenheit scale. Understand? It is very important. Here, see, temperature we are going to consider 273, right? It is not actually 273, it is 273.15. It is a standard one, but by rounding off we take here 273. So here our Celsius, 1 Celsius is 9 by 5 days with the Fahrenheit scale. Here also the ice at 0 degrees Celsius is 32 Fahrenheit. When you are saying Celsius at 0 degrees Celsius, when you apply here, if you do this calculation, you will get 32 Fahrenheit. Steam point at 100 degrees Celsius is 200 Fahrenheit. So you have now differences between what you mean by heat and temperature. Nearly 6 points are there in each side. 6 points are there. Okay. I will be, you just go through that. It's very easy. Whatever the concept we have seen now, it's there. For the next class, we are going to study about anomalous expansion of water, and we will see that what are the things it is in. So until then,